The only way that I can think of to solve this question, since the answer choices are very close to one another in terms of their sizes, is to draw a diagonal connecting points B and D, thereby creating two different right triangles. Now the idea is that for the upper right triangle, we have the sides of 3 and 4, and if you've memorized your Pythagorean triples, which you should, you know that one of them is 3, 4, 5. So that's a quick way to realize that the diagonal that we just drew, the length of that diagonal is exactly 5. Then we look at the bottom left triangle. It's also a right triangle, so we can use the Pythagorean theorem, because 1 and 5 don't seem familiar to me from any of the triples that I've memorized, so I'll have to use the Pythagorean theorem, which says that the sum of the squares of the two sides equals the square of the hypotenuse. So 1 squared plus something squared, the thing that we're trying to find out, equals 5 squared. Moving things around a little bit in that equation, namely subtracting 1 from both sides, we get that the thing we're trying to find squared equals 24, so the actual thing is the square root of 24. Now unfortunately, the square root of 24 is not in the answer choices. That just means that we have to get the prime box of 24, which is 2 cubed 3 to the power of 1, and then see from that prime box what can we extract because they are themselves squared. If I rewrite this prime box as 2 squared times 2 to the power of 1 times 3 to the power of 1, now I can pull out the 2 squared and say this is just 2 multiplied by the square root of 6. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.